Hey, this is Josh with Incompetech. Welcome back, and I know it's been a while, so sorry about that, and I'm not sure how often I'll get around to them, but I'm trying to come up with things that are actually useful. So here's one that I think we'll all get something out of, and something that's going to actually benefit us. Secure DNS requests for everyone. Why is that important? Why do you need to have secure DNS requests? Well, you can read the screen, but I'll lay it out for you in layman's terms. If you don't secure your DNS requests, i.e. encrypt them, your ISP or anybody else on the line can actually pick up those requests and start making data gathering information based on where you're going. So let's just say your ISP is the one doing it. So whenever you go and log on to their site, you're going to get more ads based on the stuff that you're going to. Not a huge big deal, but I personally don't like anybody tracking what I do. And if you want to keep yourself secure from prying eyes on the web, securing your DNS requests is the first step, and a major step. Even if you don't care that anybody's tracking you, it's coming. Eventually, secure DNS is going to be the default, but it's going to be a while. Even though, like number 2 says, the RFC was ratified in 2016, nobody really has a client out there for Windows, Linux, Mac, or any of the major operating systems that automatically does all this for you. So you have to find some form of a workaround where people have either created an application that does it for you, or you have gone out and wrote your own scripting and done it yourself. So I went out and did a little research to try and find something that works for everyone on the 2 major operating systems, Windows and Mac OS. So how does it protect you? Well, it keeps ISPs or anybody from being able to see your DNS requests. Now, granted, most of us don't have to worry about man-in-the-middle attacks or hackers attacking us, because they're not really out there looking for Joe Blow, on the street. They're looking for companies or people that work for big companies that have a higher level within the company, can get them the information they need. So for the general public, the man-in-the-middle attack or an attack from hackers is not as big of a deal, but it's still feasible. If you ended up with a virus on your computer that is really a window for a hacker to see what you're doing, or at least a start for them to get the information, they could then use DNS spoofing and other things to steal your traffic and guide you where they want you to go, thereby, let's say, instead of going to your specific bank and logging in, you're going to their website that looks like your bank and giving them your credentials. Things like that you don't want to happen. So to start off by protecting yourself, DNS encrypted is where we're headed. So what's a DNS request? Just lay this out there so for everybody to be on the same page. Every time your computer tries to go to a website, let's take foxnews.com like I have in the example here. Your computer sends out a request to a DNS server that says, please send me foxnews.com. That server then goes out to some other servers, grabs the authoritative server's information, then goes to that server and says, hey, what is the IP address for www.foxnews.com? And that server returns to the server that you asked for the DNS name for, that IP. That server then that you requested the foxnews.com for, then sends you that IP. Your browser then in turn sends your request to the IP address that you were just given. So in this example, Fox News would be sent to 23.40.180.93. And that's all done in DNS in the background without you really having to do anything. Imagine having no DNS, and we'd have to memorize every single server's IP. The internet wouldn't exist today, basically. So DNS is key. DNS plays a huge point in how we do things. So why haven't we secured it? Well, hopefully after today you'll know how, and you will. So typical DNS requests, here's what you're going to see. The next slide is going to be like what it looks like, what I just explained simply, in a more complex flow. So as you see, the computer on the top left says example.com. They're trying to get to example.com. So number one, they send the request to, and number one is right here. They send the request down to a DNS resolver. The DNS resolver in turn sends it out to a root server that says, give me the top level domain server, which the root server responds, and the DNS resolver goes to the TLD server, which is top level domain, which is, if you're not familiar with, the root servers list out all the TLD servers. The TLD servers in turn list out all of the individual domain servers, i.e. example.com. So when you went to the TLD.com, it would then send you to example.com down here. Now, example.com would in turn give you the IP address for example.com, and that's number 7. What happens here is the DNS resolver now sends you, hey, example.com is at address whatever, number 8. Your computer now will go out to that server on number 9, and that server will then respond back to you on number 10. That's DNS in the whole. So what's secure DNS? I'm sure everybody's familiar with secure web pages, like go into your bank, it says HTTPS for secure pages. And we do that to protect ourselves because the data that we're sending to that site is encrypted, including your username and password. Of course, that being a good thing because we don't want anybody out there to be able to see in clear text our username and password. Now, we're not really sending username and passwords to DNS servers, but it shows a traffic pattern and it shows the types of places that we go to, and they can then watch what we're doing. So it's the first step for people to figure out, hey, this is what this person does most of the time. So why aren't we encrypting it? Well, for one, Microsoft and Apple are slow when it comes to making changes based on the IETFs, RFCs, or other things. Sometimes it takes them years and years to get around to actually implementing whatever the IETF has ratified. And in this case, because this was ratified in 2016, I'm hoping we'll start seeing something in all OSs in 2019. But I'm not going to hold my breath for it. So why DNS over HTTPS? Well, simply put, HTTPS is one of the most used protocols today. And typically, no matter what network you're on, whether you're on your office network, your home network, your Wi-Fi, your cellular, whatever the case may be, HTTPS is 99.9% allowed to go out from that network to the internet. So securing your DNS requests with HTTPS almost guarantees that no matter where you bring your PC, whether it's a laptop or your phone, granted this won't work on your phone, but you know, if it's a MacBook or a PC laptop, whether you're at home or whether you brought it to the office or whether you're in Starbucks cafe, you'll still be able to secure your DNS requests using this method. So the secure DNS solution, here's what I found. The majority of the people that are going to watch this video is going to be able to do this. Not everybody runs Windows or Mac, so for those of you who aren't, this isn't for you yet. I haven't tested or looked at how to do this on anything other than Windows and Mac, even though I am a huge proponent of Linux. It's not a operating system that's used by the majority of the people today. So I'll get around to trying that at a later date. So to start off with, go to simplednsscript.org and look for your specific download on that page, whether it's the Windows or the Mac version. Then once you've downloaded it, run the install, and when the install is complete, you'll get this GUI that pops up with a few sections in it. The top section looks like what you see here. Make sure that those items that I have checked are checked, and go to the next section. Make sure that DNS Crypt service is the black bar on the right is actually all the way to the right, because initially it'll be to the left. So you want to click it and make sure it moves to the right. Then you want to go down to the bottom section where it shows your Ethernet adapters or network cards. Check the ones that are active, and if you have more than one, like if you use a laptop both plugged in and Wi-Fi, do show hidden adapters and select them all. Then go back to the top where you had the checkboxes, and on the far right it says apply those settings. Go ahead and click the apply settings button. Now let's go and check and verify that it actually set it. So open up a command prompt, and to get to a command prompt, you either go to the start window and search through programs and all that, or in your computer, if it's Windows 10 where it says type here to search, just type CMD and hit enter. Once you've got a command window open, type the ipconfig /all and look for where I have highlighted in red. It should read DNS servers, and it should say, one of them at least, say 127.0.0.1. That means that Simple DNS Crypt has been installed and actually changed your system appropriately. Now, the one other thing you want to do at this point, and I'm going to go ahead and bring up a window to show you. So here's a command prompt, right? What you want to do to make sure that your DNS crypt functions properly, just type in ping www.google.com, and it should respond with an IP address and some responses. That right there says that DNS Crypt installed, made the changes necessary, and your DNS is actually working, and you're getting responses, and it's actually encrypted. That's it. That's the simple steps. That's what it's going to take to get your DNS secure, and hopefully you guys will use this, and if you have any questions, let me know.